Hello viewers, my name is Sanjay. I am from group number 1. We are here to present our CI activity of FCS. Our topic is a step response of the unity feedback first order system. My group members are Adesh Nirmal, Rishikesh Rahane, Sanket Rahane and Sanjay. Let's continue our video. So viewers, we have completed our introduction. So we start our MATLAB program. MATLAB program for step response. We have created from this home tab. We have created a new script, and now we are writing our program. First, we write our first command of CLC. CLC is used for the clear the screen. Then the next command is num. Num is used for the step response of the numerator, and its values are 6, 0 and 1. Then the next command is den. Den used for the denominator of denominator, and its value is 6 and 1. Then the next command is sys. Sys is a system command which is used to perform the operation tf into numerator comma denominator. Tf is used to give the input to the our step, to input to the step. Then our second last command is a step. Step means we have writing the program for the step response, so we have to include the step. Step comma sys. Sys used for to take the input from the sys command. And the last is a grid. A grid used to get our graph, our final output from this program. We have write our program, so we are save our program as our name. And now we run our program. In this editor section, there is a run command. We click on the run command. So viewers, this is our output for the step response. Thank you.
Now we will be doing the simulation of step response. First we go to simulate, then the blank model. That we are doing maximizing the screen. Nextly, the first component is the step. We are typing the step. Then we will be deleting the step. Nextly, we will be taking the sum. Here we get sum, but as we need plus minus, so we will double click over here. In 1 plus, we will be deleting 1 plus, and instead of 1 plus, we will be taking a minus. It takes some time. Next is the transfer function. Here we will set the numerator and denominator. Here we need 0 and 1. And in denominator we need 6 and 1. Set. Nextly, we have to take the mux connection of an two components. Next is the scope for seeing the graph. Now all the components are taken. Now we will be attaching the components to each other. Firstly, connecting the step to the sum. Nextly, sum to the transfer function. Taking one connection of transfer function to the sum negative. Nextly, the connection of one mux will be connected to in between the step and the sum. Next, now we will be saving this file. Now the file is saved. So we will run the program. And this is the output of our simulation. Thank you.
As I explained the step response program, then I will explain the impulse program. This starts. First we will clear the screen CLC for that. Then we take the numerator that numerator is equal to 0 and 1. Okay. Then we will take the denominator for our function. Denominator is equal to 6 and 1. Okay. Then we will take we have to calculate the transfer function. We will take the system C is equal to that transfer function in the bracket numerator and denominator. Then we will calculate our impulse function. So impulse is equal to system is there. Okay. Then we calculate for graphical method we have to use the grid command, right? Grid. Then we save our program as the name of program command. Okay. Save. Then we will run our program with that. So you can see the output is very good. That now our program is successfully run. We have to see the output in our screen.
As previously, Sanket is explaining first order for standard signal steps. Now I am going to explain for sine response. First we go to our simulation, add new black model. Now we take components. First was sine wave. Now rearrange that. Secondly, we take some third one is the transfer function. Fourth component was that takes multiple input into single output. Now our last component was scope to view our output. Now we can arrange that. First sine go to the sum, and summer input is going to the transfer function. Transfer function output is towards the mass. Next one input is from sine wave hour. Just make sure that they are properly connected to our connection line. second input was to the transfer function output. Now we set our summer value plus minus. For feedback region. Now transfer function input numerator was 0 and 6. Denominator was 6 and 1. Apply that changes. Here our transfer function will be and marks. Function was ready. Now we have to save the file. Now we are run our simulation. Step 10. This was our output for sine response for first order system. Thank you. Now we conclude our activity. First we learn programming by first order signal by standard signals, its steps and impulse. Now lastly we learn about simulation by taking standard signals, steps and sine waves. This is all from our side. Thank you.